Okay, good morning class. So at this point we're looking at chapter 6, we're looking at trigonometric equations. At this point in our last lesson we had some load shedding as we had in the lesson before as well, and still nobody wants to become electrical engineers to sort out the issues. But we drew the sine graph, and then we spoke about the general solution and all of those things. And we spoke about K, and we had all the colors on the board and all of those things. Okay. If you want to get the full explanation of that as well, you can go to the full lessons in the description box below. Okay, so now we're going to look at trig equations. As I've also indicated that you won't necessarily need to draw the graph every time when you're doing general solution. Imagine you must draw this graph every time. Hectic, no? And then it's not worth that 7 marks that it's worth. Because you're going to take a lot of time, and you need to buy new colors, and all of those things, okay? Which many things you don't have, no? You got the money, but you don't have the time, and you don't have the energy to spend so much time on only 7 marks, no? Those 7 marks would be 7 more than we normally get. I'm joking. Okay. So trigonometric equations, solving equations. We're looking at the examples for exercise 7.8. And exercise 7.8 is on page 211. Right. The example is on page 210. Okay. So the question says, so just coming back to the one that we did quickly before I actually go into the one that we have as an example. Okay, so I'm just going to take this out here. So I'm going to use the example that we used in our last lesson on Friday. Okay. So the question was, determine the general solution for sine of x is equal to half. Okay. So what we did was we said, okay, what we will be doing is, the first step is to get the trigonometric ratio on one side and everything else on the other side. Okay, so if you want to make notes, that's going to be your first note. You do trigonometric ratio on one side and everything else on the other. So it's either you're going to have tan of the angle or sine of the angle or cos of the angle there. Okay. Okay, so the next step is to determine the reference angle. I'll explain now what's going on there. The next thing is to determine the reference angle. Okay, now how do we determine the reference angle? We say reference x is equal to arc sine of a half. Arc sine of a half. Okay, and she's calling out this 30 radians. So how do we do that? We say shift sine of arc. First get it in the proper, in the normal mode. So shift sine of arc sine of a half gives us an answer of 30 degrees. Okay. Can you see that 30 degrees is coming up again? Alright, now what do we do? Determine in which quadrants we sign positive. Determine in which quadrant the trig ratio is. So you must write now. No? Determine in which quadrant the trig ratio is positive or negative. Okay, in this case it's going to be positive. Okay. Why? Because the half was positive. You guys understand? What if that half was negative? Now check in which quadrant, in which quadrant the trigonometric ratio is negative, if that was negative, where it stands positive. But if there is no sign, we know it's positive. Okay. So let's go to the diagram. Okay. In which quadrant is sign positive? Quadrant 1 and 2. How do I get in quadrant 1? In quadrant 1, I'm going to say x is equal to, in this quadrant is this theta, there is 180 minus theta, this is 180 plus theta, and this is 360 minus theta. Okay, that you can make a note on the side. So it's in quadrant 1 is only the angle. The quadrant 2 is 180 minus the angle. I'm not going to say 90 plus. Why? Because the whole trigonometric ratio for sine and cos will interchange. Can you see that? It becomes co-ratios. How do we get into quadrant 3? 180 plus. How do we get into quadrant 4? 360 minus. Okay. Alright, so we get into quadrant 3. We say it's going to be the reference angle, which is 30 degrees plus k times. Now, that, to get back into this, if I say this is your theta angle, to get back into the theta angle, what do I do? I add 360, and again 360, and again 360, and so on and so on and so on. Can you see that? In our previous lesson, we actually did it with the graph. And if you want the full lesson, you can find it in the description box below. We have explained how we get this k times 360. Okay? So it's time k times 360 degrees. On the sine and cos graph, it will always be k times 360. Why? Because the period on the sine and cos graph is 360. So if we add a tan there, what would it be? K times 180 degrees. Does it make sense? So that is the quadrant 1, or it will be in quadrant 2. Okay, in which are we getting quadrant 2? We say x is equal to 180 minus the reference angle. What's the reference angle here? 30 degrees. I'm going to put your RA rather, reference angle. Okay. So that's going to be 180 minus 30 degrees plus k times 360. So x is equal to 150 degrees plus k times 360 degrees. And what mustn't I forget? Must always say here that k is an element of integers. Why? Because I brought the variable into the equation. Can you see that? So we must specify the nature of k. Okay. So the last step is, so we said the first thing is you must get a trigonometric ratio answer. Then we work out our reference angle. Then we take it in which quadrant is the ratio positive or negative. It will always be positive in 2 and will always be negative in 2. Can you see that? It will always be positive in 2 or negative in 2. Okay. And then we take it to its branches. Okay. And don't forget, k is an element of integers. Okay. We leave that out. Okay. Every time you leave that out, you lose them off. And this is suffice for both these solutions. Okay. Just write it once. Okay. So now let's look at, now coming back to if they ask you solve for x is an element of, they give you now a restricted domain, and they say x is from 0 to 360. Okay, now we say x is now an element, and we start listing. What we do is we start with k is 0. Okay, we start with k being 0. So we say 30 plus 0 times 360 is going to give you 30 degrees. Then we do k is equal to 1. If I put 1 in here, it's going to be 30 plus 1 times 360, which is 390. What do you notice? It's outside this given domain. So do I write it down? No. If 1 doesn't work, will 2 work? No. And 3? And 12? So once you go into the positive and it doesn't work anymore, you stop. Then you go to the negative. Okay. If now I put negative 1 in there, it's going to give you negative 330. Is that inside or outside? Outside this given domain. So what do? I stop. Then I go on the other branch. I start with k is equal to 0. Put 0 in here, I get 150. If I put 1 in here, it's going to give you 4, 5, 10, nothing. No? Which is outside. If I put minus 1 in here, it's going to give you negative 210, which is also outside. So what do? I stop. Okay. Now we'll be running out of time, yeah? Come inside. Somebody knock now? Okay, they probably don't want to come in. Okay, so come inside. So let's pause here quickly. Okay, so we just have button press for time, yes. I'm just going to try and go quicker through this here. Again, if you don't understand, the full lesson will be in the description box below. Okay. So again, we're looking at the example on page 210. It says solve for x for sine of x equal to negative 0,893 for x in the element of negative 360. Correct one, decimal place. So now you don't have to work out the general solution first. You don't have to, because there is no mark allocated for the going into the full mark. Okay, but just do always the general solution first, because in the same time you can practice or master determining the general solution anyway. Okay. So what we do is we then say sine of x is equal to negative 0,893. People, is that already having the first bullet in which we wrote down? Is the trigonometric ratio on its own? Yes. So what do I do now? I work out the reference angle. So I say arc sine of 0,893. What do you notice? I didn't take the negative. Okay, so I always work with the positive ratios. Why? So I have a positive outlook on life. Okay. If you that negative kind of go, leave that things at home. Okay. So we're going to work with the positive part of it. Okay. That's why we call it the reference angle and not the angle itself. Okay. So the reference angle, so we say shift cos or arc cos of 0,893. That gives you 63,25. So 63,25. So 63,25. So what question comes to mind now? Which quadrant? Is sine negative. Why negative? Because just before I took the code, what's the name? The arc sine. At that point, I take the reading. Is it positive or negative? Okay. So in which quadrant is sine negative? 3 and 4. Okay. So how do we get in quadrant 3? So it's going to x is equal to 180 plus 63,25 plus k times 360. So x is equal to, put in your calculators, 180 plus 63,25. 43,25. plus k times 360. Or quadrant 4. How do we get quadrant 4? X is equal to 360 minus 63,25 plus k times 360. So x is equal to, work that one out. What do we get? Sorry? 296,75. But what do we notice here, people? It's a restricted domain. So what we do is, we say x is an element of, and you start listing. If I put 0 in here, I'm going to get 243,25. Is it inside or outside this? It's outside. It's more than 0 most. So would I try 1? No. What would I try now? Negative 1. So put in the calculators, 243,25 minus 360. Or 243,25 plus negative 1 times 360, the same, which is negative 116,75. Try minus 2. Definitely is less than negative 360. You guys understand? Right. Let's go here. This is plus k times 360. If I put 0 in here, what's going to happen? It's going to give you a value more than 0. Not so. I put minus 1 in, what do we get? I forgot to put here that k is an element of input. I would have lost now 1 mark. Yes? If I put minus 2 in here? Shucks.
Good morning, may I have your attention, please?
We'll be outside.
A reminder that there will be an RCL meeting now during first break, and it will be in the room 43. The auditions for the RCL event will take place at second break and after school, also in the room 43. A reminder, I have 2 water bottles in lost property, and Ellen Finch, can you please report to the office?
Okay, so I know it's break now. So the first part of next lesson, I will do the remaining of this recording. I am free, so I'll post it in the group. For our work, I would like you guys to do 6.8, the odd numbers. Okay, you will enjoy the rest of your day, and I'll post the video later. Okay, as promised, I'm back. So let me just check how far did we get. So now we're looking at the second example on page 210.
She said she is not done making copies, so she might borrow it later on.
Okay, but
This one.
the general solution of 3 sine x minus 3.4. 3 comma 4 is equal to negative 4 comma 456. Okay. Okay. So as we said, the first thing that we need to do is to get the trig ratio on its own. Okay, so what I do is I take that negative 3,43 over and then divide it by 3. So sine x is equal to negative 4,456 plus 3.4. That answer must then be divided by 3. So sine x is equal to negative 4.456 plus 3.4, and that's all over 3. Okay, so that's negative 44 over 125, which is negative 0,352. negative 0.35. Okay. So what we now do is, since we got the angle on its own, we're going to work out our reference angle. So we say arc sine of 0.352. As we know, we're dropping the negative also at this point. Okay. Computer's not charging. Okay. So now please shift sign, arc sine of that answer. Or a shift sign of 0.352 gives you an answer of 20.6. The reference angle of 20.6 degrees. Okay. I think the previous sum was also to one decimal place, I think, and we worked to two decimal places. That must just be negative 116.8 and negative 63.3. Sorry about that. Just realize now they want you to work with to one decimal place. Normally if it's not stated, we work to two decimal places, okay? Or specified, and we go according to the specification made. So again, we sign negative. So we ask ourselves in which quadrant is sign negative. Sign is negative in quadrant 3 and 4. So let's go to quadrant 3. Quadrant 3 is, let's pause here quickly. Come inside. Alright, so that is going to be in the third quadrant. Is going to be x is equal to 180 plus. Remember, in the third quadrant is 180 plus, fourth quadrant is 360 minus. We're not going to use 270 and 90 unnecessarily there. Okay, so it's going to be, otherwise sine changes to cos and cos changes to sine. Okay, times 360. Why 360? Because the period on the sine and cos graph is 360. So it's 180 minus that answer. It's going to give you 159.4. So it's 159.4 degrees plus k times 360. Okay. Or in quadrant 4, how do we get in quadrant 4? It's going to be x is equal to 360 minus 20.6 plus k times 360. Okay. So that's going to give you 360 minus 20.6. Okay, that's going to give us 339.4. 4 plus k times 360. Where k is an element of integral. And the question was for general solution, so we stop there. Okay. I made a mistake here. Should have been 180 plus. It's 180 plus 20. So that is going to be, sorry about that, 180 plus 20.6. I'm struggling again. 20.6. It's going to give us 200.6. So that is 200.6 plus k times 360. In the textbook I see that only there is one solution there, but they don't pick the solution up here for some reason or other. Okay, let's carry on. Sorry about that mistake again. That's tomorrow's lesson. So we're looking at the third example on the section. General solution. Solve for x. For 4 sine 2x plus 10 is equal to 2 root 3 for x is an element of negative 90 to 540 without the use of a calculator. Okay, so where do we go first? We get the trig ratio on its own. So it's going to be sine 2x plus 10 is equal to 2 root 3 divided by 4. So that's the same as saying sine. Sorry about this. Then give us again sine 2x. Do you know align the board again? Sine of 2x plus 10 is equal to root 3 over 2. Now that should remind you of the special angles. So that's 30, so it's 1, 2, root 3. So how do we get the root 3 over 2? If it's for sine, it has to be 60. So my reference angle of 2x plus 10 is equal to 60 degrees. Also note here, I have not taken the 10 over the equal sign, nor have I divided by 2 here to get rid of that 2. Okay? So remember that? We're never going to do that, okay? So what are we saying? We ask ourselves, in which quadrant is sine positive? As before we took the reference angle. So sine is positive in quadrant 1 and quadrant 2. Let's go to quadrant 1. So 2x plus 10 is equal to, quadrant 1 is only the angle, so that will be theta, and this is 180 minus theta. 60 degrees plus k times 360. Why? Because the period on the sine graph is 360 degrees. Okay? So a matter of solving for x here, so 2x is equal to 60 minus 10 is 50 plus k times 360, now divide by 2. So x is equal to 25 plus k times 180. Okay, did I write here that k is an element of, yes, I did. Okay. That is quadrant 1. So I'm going to take this off here. Go and pick up the dust at this point. Otherwise the board will jump again around. So I'm going to look at quadrant 2 as well. So it's going to be 2x, which is the reference angle, plus 10 is equal to 180 minus the reference angle of 60 degrees plus k times 360. Okay, so I take that over, it becomes 2x is equal to 180 minus 60 is 120, minus 10 is 110 degrees, plus k times 360. Divided by 2, so you get 55 degrees, plus k times 180. Where k is an element of integers. However, there's a restricted domain on this question here. Okay? So my question is restricted to negative 90 to 540. So x is an element of. As I said, if this question is asked, you don't have to work out the general solution. Okay? But since it is a practice for us on general solution if we do these sums, so I do it anyway. Okay? So what I do is I start with the one branch. Okay? And substitute k is equal to 0. Remember, it must fall within this domain. So I put 0 in there and get 25 degrees. If I put 1 in, I'm going to get 25 plus 1 times 180 is going to give you 205 degrees. Okay, let's just confirm that. It's 25 plus 1 times 180. What does it say? Plus 180 is 205. So that is 205 degrees. Now we put where k is 2 is 385, which is still in the given domain. 385. Let's carry on. Put the 3 in there. 565. So that is outside the given domain. So I don't even write it down. I put the negative 1. It's negative. It's negative 155, which is outside the given domain of negative 90 to 5. So that's now exhausted. Now we go with the other one, okay? The other branch. So we put again 0 in where we see k. So of course we're going to get 55 degrees. Okay, normally I put a listed here next to it, no? But because of the space here, I'm going to write it below. Okay. So if I now put 1 in, let's see what we get when you substitute 1. Okay, so it's going to be 55 plus 1 times 180. Okay, it's going to give you 235. 235, which is within the given domain. Let's now go with 2. It's 415, which is still within the given domain. Okay. Let's put 3 in. It's 595. So that's again outside the given domain. So let's put negative 1 in. It's negative 125, which is also outside the given domain here. Okay. So x is equal to 25, 55, 205, 235, 385, and 415. So that's the solution. So with that, you should be able to now do exercise 6.8 on page 21 for homework. Okay. At this point, we'll stop the video again. I know I gave you the odd numbers only. So in the next lesson, we'll mark the odd numbers first. Again, the full lesson can be found in the description box below.